Good afternoon, everyone. Welcome to the webinar organized by Eurescom on behalf of the reTHINK project, how to return control over user data and give it back to the user. And our colleague Anastasius Gavras from Eurescom will today explain how the reTHINK framework will actually help in achieving that. We will start on time, so I hope everyone is comfortable and has managed to connect their audio. Just a few organizational instructions. If you have any problems with the audio, just put your question in the chat. My colleague Klaas, our technical manager, will take care of it and will try to help you. During the presentation by Tassos, please mute yourself so we don't have any background noise. I think that's the case for basically everyone. If you have a comment or question on the presentation while it's ongoing, please share it via the chat and we will come back to that. I will collect them and just mention them and put the questions forward to Tassos. And of course, in the Q&A session, you can of course unmute yourself and directly ask your questions. This call is recorded, so if you do not like your voice or your face or anything recorded, then better leave now. This is a public webinar organized by Eurescom on behalf of reTHINK. My name is Milan Gupta and I have the honor and pleasure to introduce my colleague Anastasius Gavras, Tassos Gavras, who is the coordinator of reTHINK, and he will explain in a brief presentation the reTHINK framework. Now, Tassos, the floor is yours.
Thank you, Milan. I hope everyone can hear me. On the chat, I was seeing some people that could not hear the voice. Maybe you can check out if everything is all right, but nevertheless, I will start. Thank you everyone for joining this webinar. I will try in the next 20 minutes or so to give a run through what has been done in this project we call reTHINK. So it is basically a 30-month project, so it is impossible, of course, to cover everything. So I will try to focus on one of the issues, which was the question of how to give more control to the user over its own data or during the communication session that he's engaged in. Now let's see a little bit on the background and the motivation of the project. We started basically by comparing the two worlds, the classical telecoms world and the so-called OTT or the TOPS world. And there we can see that while in the telecoms world we have a kind of a very strict structuring of the service and the identity and the platform and the infrastructure and everything. On the OTT world, we have a kind of loose coupling of these things. However, the identity usually or almost always is tied to the service. So if you are a customer in Facebook, you have your Facebook identity, you can use the Facebook services. The same happens also in Skype. So your identity in Skype is tied to the service that Skype is providing, and so on and so forth. Now, we said that this is perhaps something that we can actually uncouple, so uncouple the identity of the users from the services that they use, and apply a very cooperative distributed model for service delivery. So we started, in fact, by applying certain principles to the whole communications world, if you like, and we said that first of all we need to get away from the silos. So the silos, as I said, when you are a customer of one service provider, then you are basically tied in with your identity to that service of that service provider. So we think that the situation should be different, so that the customer is not necessarily tied to an identity that is provided by the service provider, and even more. We can see on the web today many different services from many different providers that some people would like actually to combine, because the combination of two worlds, so two services from two different worlds, is something that gives added value to a certain user. Now, this is today possible to some extent, but still quite cumbersome. So we think now that decoupling this identity with from the service will give us the opportunity to achieve a number of things. The first thing is, of course, that we can use the identity service in a very different way. And in fact, what we also try to achieve here is to give back the user the choice of what identity he wants to use in order to connect to a certain service. There are different levels of identity, of course, here. Identity, also the strength of the identity assertion, which can be used. For example, we can have even anonymous identities or pseudonymous identities to use a certain service, provided, of course, the service provider that offers that service is comfortable with an anonymous identity or a pseudonymous identity. Obviously, to use let's say, a banking service or something in this area, you certainly will be required to use a strong authentication or an identity with a strong assertion behind. Now, we can use, of course, also different identities with the same service. In fact, this is somehow, if you like, a core feature in the reTHINK framework, so it is something embedded. Now, if we do that, if we decouple the service from the identity from the service in a certain provider, then we have immediately the question that that someone has to also be able to discover services and discover also peers. For example, in the when you are a customer of a certain service, let's say A, and your friend, your colleague is a customer of service B, then there is a need to, of course, discover this peer. Now, this is also an inherent feature of the framework that we have developed. We call this protocol on the fly or protofly, and I will come into more details on that. We see this protofly feature as a kind of a universal plug to plug together services from different providers and the identities of the peers that want to communicate. Now, we have also decomposed the applications and the complex services into what we call hypertext, which stands for hyperlinked entities, which effectively are microservices that can be deployed just in time and can be used to form complex services in application, and are basically reusable building blocks. So a hyperkey is sort of a minimum set of functionality that is required to make up some meaningful business logic. Now, an application developer that uses the framework basically would combine a number of hyperkeys or hyperlinked entities and then put together the application. Now, the mechanics of how it works is a little bit complicated. One of the reasons, of course, is that we decoupled, of course, this service from identity, and we also have the decoupling of or the discovery of the different hyperkeys and the different identities. So the whole framework has been implemented based on state-of-the-art technology, web technology, in fact. We currently claim, and in fact show also in the implementations, that we do not need anymore to specify or standardize communication protocols, but rather we rely on a common data model of a service, which is the only thing that, the only agreement that is needed for inherent interoperability. So the hyperkeys basically are protocol agnostic. They incorporate an agreed data model, They run in an execution environment in the device of the user. We can have it also running as a proxy in the cloud. That is also possible. We have demonstrated that as well. And due to that, in fact, they are inherently interoperable. Now, going a little bit more into the technical details, we are relying here in the framework heavily on messaging. So we have three different levels of messaging. So we have at the runtime sandbox level, basically the device level communication. There is this message bus component that is responsible basically to move back and forth the different messages that are exchanged. You can see the messages that are exchanged as a sort of replacement of the signaling that is going on in traditional telecommunication environments. So I won't go into much detail on that particular figure, but I will try to illustrate to how this in fact works, and also how the so-called protocol on the fly works when, for example, establishing a session and the different services, which basically can be the same service from a user perspective, but work differently at the lower level. So here we see a basic procedure starting from Alice. You know the typical Alice and Bob example here. We have Alice's device. We have the Alice's service provider, which has a catalog of hyperkeys, and in the catalog there is also what we call protostat, which is basically kind of a short acronym or term for protocol stack. Which is maintained and provided by the service provider domain. Now, when Alice tries to connect to the network, this basically login. Then what happens is that the protocol stack is retrieved from the catalog of Alice's service providers with the help of a user agent, so the runtime user agent executes that, and attaches to the protocol stack sandbox. Then the next thing is, of course, the actual hyperkey itself, which is, as I said earlier, the business logic that is implemented by this particular hyperkey. When this has been done, then the communication is, the messaging is basically taking care that the instance of that service logic or that business logic is registered by the so-called hyperkey instances registry. Now, this is necessary, of course, in order to be able to recognize that Alice is logged into a particular service and is able to use a particular functionality, which is whatever is behind this hyperkey one. Now, the same happens also on Bob's side. When Alice tries to reach Bob, now from the service provider of Bob, he also the service provider of Bob is now downloading into the device of Alice the protocol stack for the service on his side, so that the hyperkey H1 can communicate with the domain service provider domain of Bob. The same thing happened there with the registration. And now what we have is that we have basically all we need in order to establish the communication between Alice and Bob. Now on Bob's side you see hyperkey 2 is basically the same functionality, so the same business functionality, but implemented in a different way. Alice hyperkey H1 is provided by Alice's service provider, and H2 is provided by Bob's service provider. So here the registration happens as well, so that the communication goes via the protocol stack of service provider of Bob into the hyperkey of the respective hyperkey of Bob's device, and then when this is done, when this message exchange has been done, then the media stream can start working between H1 and H2, so basically hyperkey 1 and hyperkey 2. Now, as you saw, many things here happen on the fly, so also, well, In addition to the hybrid functionalities of the basic service that Dan is going to use, also the protocols that are necessary for that downloaded to the respective devices of Bob and Alice, and the media stream is then established based on the data model that is behind the hybrid functionality. Okay, so let's go now to the Yes, I think I covered this. This is the protocol stack that, or the protocol on the fly, the proto-fly concept that I just described, basically meaning that everything that is needed for a certain communication session is downloaded, is put, if you like, from the service provider domains into the devices of the peers that want to communicate. Now, this protocol on the fly leverages the code on demand support by web runtimes, for example, JavaScript. And of course, usually the most appropriate protocol stack is dynamically selected rather than instantiated during runtime. Now, let's look at the trust model. What's happening here? Now, everything in the previous images that we saw are executed basically in what we call sandboxes. Because of protection. So in many cases here we download the code, of course, from a different service provider into a user's device. So we want to make sure that certain things that relate to security are basically assured. And because we have now also a communication with a peer that may not be actually known, we have designed this trust model, developed this trust model, which basically works with identity tokens, which are generated, inserted in the intercepted messages that are sent by the hypertext, validated by the recipient side hypertext runtimes before delivered to the target identity. Now, this also is backed up by policies, which can be managed by the end user, and so the end user can actually say at any time and at any context what type of connections he or she wants to accept. Now, if we analyze this more carefully, you see there that the first step is, of course, that an outgoing message from the left side is intercepted by the policy engine and the identity module. The identity module generates the assertion, and you can here see. Let me see if that works. You can see here we have here also an identity proxy, an IDP proxy sandbox, which also helps us to deal with separate identity providers in different domains. So this generates an assertion to the identity provider, and when this assertion is successful, then the message is basically passed over, including this identity assertion. Now, on the right side, of course, the same happens in the receiving process. So the receiving the incoming message is intercepted. In step 4, it goes again through the IDP proxy on the right side to basically validate the assertion. When the assertion is validated, then the message is validated and forwarded to the device of the user. Now, in the big picture for the identity support services, we have a number of, if you like, components that run in the framework and support all this story of the different hypertext and securing the different hypertext against the different types of code that are downloaded, the discovery of what is available, the discovery of the identities or mapping of the identities, and so on. So I'll try to go through a few things here. So we have, of course, basic support services like authentication and capabilities of authentication to user. which also is in fact asserting which identity he wants or she wants to use for a particular service. So at the time of the login, the user tells the service provider with which identity he wants to or she wants to log in. Of course, we identify authenticated users through that framework and provide identity tokens for the peers. We check the identity tokens received by the callers, and by this we add trustworthiness value also to identity, which can be based also on which can also be based on the graph, or the social graph of the user. One important element here is the runtime registry, which is keeping track of all the registries that, which are all the hyperkeys that are activated for the user, and of course the policy engine where the user is then able to define what he or she can allow or will allow to do with this identity. Now I will try to well, this is in fact an illustration that shows in fact all this process that has been already discussed earlier in the trust model. It's basically a different image of that. So everything goes via the identity providers of the two peers, so that the identity provider of Alice asserts the identity of Alice, the identity provider of Bob asserts the identity of Bob. And here, as you can see, we have the trust engine here, where we then evaluate the trustworthiness of the identity assertion. Now, an important point was, as I mentioned, the discovery itself, because if you are in a separate, if you as a user have a separate domain, then it is not a single lookup service. We introduce here a global user identity and the domain user identity, which is mapped by the global registry to a domain registry entry. And this is the way that a URL, or if you like, a URI of Bob, when he is discovered, is passed back to Alice service provider, so that Alice can actually establish a call to Bob. Right, I think this is the whole framework that I described right now. So the only thing that I could add here is that we are currently validating in a let's say larger setting the whole thing in the context of smart city application, where we use many different types of communication between people and IoT. So also things, in fact, like the service of the public transport here, so that a user that uses this smart city app is then able to establish communication with different people in its neighborhood, even to people that he has no knowledge of before, so people that are not directly in his site, but rather implicit because it's a neighborhood and so on. So this is currently being demonstrated and works in fact quite well. Now I will finish by just giving an idea of who is behind this framework. So obviously you might have guessed that a number of telecommunication operators are behind that, because what we are doing effectively here is we're trying basically to break into the OTT business model. Well, here you see the different partners that have done the work jointly. What I would like to do is finally to invite you, if you're interested, to take a look at the framework itself. You can find a number of more information, of course, starting from the main site, https reTHINK-project.eu. A number of webinars, demonstrations, existing available hyperkeys, and so on. The whole framework is open source, is open under the Apache 2.0 license, so basically you can download the framework and build your own hyperkey environment, or you can build your own applications based on hyperkeys. I think I leave it there, and I would like to thank you very much for your attention. And now I am open for questions. Now let me see if I have.
Yeah, thank you, Tassos, for this presentation. I've seen there were already a couple of questions via the chat, and I would simply ask for the remaining 5 minutes that we have, that those who asked them in the chat would just ask them now directly. I think Eleni was first. If you could unmute yourself and just ask your question straight away, and please try to keep your questions short. Thank you.
Yes, of course. Hello, Milan. My question was if do you use open nodes APIs that they are available from inside the walled gardens? My question was quite early. I suppose no, but I'm very interested, of course, to hear your answer, Mr. Gavras.
Yes. Okay. Obviously, there needs to be some sort of cooperation from the service providers of the from inside the walled gardens. Now, we do expect that, let's say, the big service providers like Google and Facebook may not be that willing to cooperate here and to expose their APIs or even provide what we call hypertext for their services, or hypertext or protostars for their services in a catalog like that. But nevertheless, on the identity side, we have already succeeded in fact attaching or using some of these identity mechanisms that are used, for example, in these other domains, like if I'm not wrong, we have succeeded in connecting the Microsoft service and the OpenID service, which are, if you like, two larger identity providers over the internet. So the framework itself is able to cope also with existing published interfaces on the web.
Thank you very much. It was a very, very interesting and exciting answer. Thank you.
Yeah, thank you, Eleni, also for that question. Next I have here is Tjerk. If you had a couple of points, Tjerk, if you would just go ahead, unmute yourself, and please ask your question.
Thank you for the talk. I was just curious if you already had done some tests, as you said, in Munich. How often and with what types of levels users actually play with their identities? That's one. Maybe we can start with that. Do people actually adjust and play with their identities, and how much cognitive load do you demand of users to keep doing this?
Yes, I understand this question. This is indeed a very important question. We have not done actual tests. We know that, but we have already, I mean, we basically review some knowledge that exists in the telecom operators about how they try to offer this type of services in their current systems. For example, Orange has been experimenting for a while with what they call dashboard, security dashboard, where the user is then able to configure certain things. Indeed, it is a kind of, as you call it, cognitive load on the user. This is indeed a problem. What we try to do is basically to define sort of classes of security or of identities. So weak identities, medium, strong identities, basically so that the user can configure once when he or she subscribes to a service, whether this one is something that he or she would like to use with a strong identity or not. And in fact, what is also possible is also to switch, of course, the identity if you enter a different level for the service request. Take the example of, let's say, of some service you want to buy over the internet. For example, let's say you are engaging in a conversation with an insurance company because you want to buy a policy. In the beginning, you would very much like to be probably anonymous. So you interrogate with the agent of the insurance company as anonymous, but when you think this is perhaps a good deal, then you can switch to a strong identity so that you can in fact actually close the contract. So this type of scenarios played also a role in when we try to assert to define which type of identities we want actually to to enable the user to choose.
Thank you. That's a very clear answer, and I'm looking forward to test and what comes out of that.
Yeah, indeed. I mean, the testing is, as I said, obviously we did not do an actual test. We think this is indeed a very big issue. But we try to say, based on previous knowledge, our best to come up with something that might be usable, handled by the users.
Okay, thank you.
Yeah, thank you, Tjerk, for your question. We are a little over time already, but if you have a little patience, we have two more questions which I think are interesting. So the first one is from Gesh. Not sure I pronounced that correctly. It's very short, but I think also very challenging. Who stores the IDs, Tassos?
A very good question. In fact, the IDs are not stored in a central place. It's basically a federation of registries, and there is a distributed hash table which is used to store these identities, especially the global user identity that I mentioned. So this is not something that depends on a single provider. I don't know if this answers that question. I see also a second question about the maintenance or operation of the global registry and the ID discovery.
Yeah, it's sort of similar. So, I mean, in terms of that ownership, you're sort of going back to the same problem as you had in the first place. If you logged in with a Facebook account, you could log in through lots of accounts, but then Facebook has the details. So there's almost like a responsibility and a liability to hold that ID. So it's just the almost like the privacy angle of that, as well as the actual storage of the identity.
Yeah, but this is exactly the reason why we decouple the source from the identity.
Okay.
Right. So we are now saying that if you don't like the Facebook to be your identity provider or holding any private data of yours, you can choose to go to someone else.
Mm-hmm. Okay.
Right, so that's why we separated the service itself. Now, as I mentioned already, the answer to the latest question was that, of course, it would require some sort of cooperation also by the Googles and the Facebooks, but in principle, the framework in fact supports that you as a user choose who to trust your private data on. And in fact, we have also implemented the identity portability, which allows someone to actually, if he's not, let's say, happy with this first identity provider to move the private data to a second identity provider and things like that. Many things are possible there.
Okay, thank you.
I hope this answers a little bit the question.
Yep.
Now let me answer the last one, or the last, it's another second one. So the global registry, who do you need to build and maintain a global registry for the ID discovery? Now, a global registry, as I mentioned, this is based on distributed hash tables, so it is technologically, based on classical, if you like, peer-to-peer technology, which is sort of easier to discover something without a central registry, and was part of the reason why it is in fact decoupled from one basic entity at the top that may also present a single point of failure. If that goes out, then everything goes out. So basically, we do not need to build and maintain a single global registry, but this is a distributed thing, logically distributed. Logically one thing, but from the implementation viewpoint, a distributed thing. And this is also coupled to some extent to the business models, because there we have now the question, in fact, always comes up, and here as well, we confirm that this question is a very important one. What are the business models behind, and how, in fact, this may alter the business models of the OTTs. Now, I cannot answer directly how the OTT business models will change. It depends on how secure a very large, let's say, OTT like Google or Facebook sees its position in the market. We see the framework here that we allow and enable all the smaller OTTs that are not perhaps dominant market players like Google and Facebook to enter in a market in a much easier way. And if the critical mass, perhaps at some point in the future, is big enough, then I think the business models of the OTTs will be challenged.
Yes, thank you, Tassos, for this answer. I know that some of you may have a couple more questions. This was just meant to be a half-hour teaser. I hope you gained some insights from Tassos' presentation, and I even hope that you may be interested in discussing with Tassos and the reTHINK team even a bit more. And if you like to do that, just kick off by sending us an email to contact@rethink-project.eu or contact Tassos or myself directly at our Eurescom email addresses, whatever you prefer. So I would like to thank Tassos for this comprehensive presentation and the audience for the active participation. Thank you very much. And oh yes, one last thing. The recording of the webinar will be available, I think in a few days at the latest, on the website and on YouTube. If you want to see it again, or if you want to share it with some colleagues, it will be there and we will inform you about it. Thank you very much, and have a good afternoon then. Thank you, and bye-bye.
Thank you very much, everyone.
Okay, thanks. Cheers.
Thank you. Bye-bye.